So, good afternoon from Dubai. We are live now on YouTube and with Zoom for Deeplearning.ai by and AI event. This is the first time we are starting this series of me versus AI. And the topic today, I think it's hot topic, especially with the participant with me. I'm glad to introduce Giuseppe Bonaccorso. He is, Giuseppe, let's say hi first. Sorry, you are muted.
Yeah, sure. I thank you very much for your invitation. Glad to be here.
Thank you, Giuseppe. Giuseppe, he is head of innovative data science in lead pharmaceutical company in Germany, and he has a lot of participating on this community. Also, I'm glad to introduce to you Dr. Tom Ivas. Welcome, Tom.
Thank you. Glad to be here.
Thank you. So, Tom, he is speaking to us from USA, and it's very early there. So I hope you get your coffee just to be wake up. Yes. So today we are talking about the explainable AI, and especially in healthcare.
I am not hearing Ghaith.
Sorry, is it okay right now? Hello. Tom?
I think it's a Tom problem.
I can see you on the camera, Ghaith, but I am just not getting audio through.
I think, Tom, it's from your side.
Yeah.
Okay. Yes. Yes. I will write.
It may just be on my end. I'll go on mute for now.
Okay. Yes, it's Tom. It's from your side. I hope this will be fixed soon. So today, as I said, we are talking about the explainable AI in healthcare, and in fact, to be clear, that explainable AI, it has the same boom right now, just like AI. When we are talking about explainable AI, we are talking about why. So, especially in healthcare, I found it very important to ask this question, why? Because we are dealing with lives. So I hope Tom is able to hear me right now, because I plan to start with him about this. Tom? Hello? I think there is a problem with Tom, so I will go to Giuseppe to ask this question. Starting from the first day we start working on machine learning or in AI, especially when we are talking about neural networks, a lot of our mentors and professors told us you have to deal with it as a black box, that you are trying to train it for special kind of output, but you don't know why this output will appear. So Giuseppe, my question here, is this really the framework of the machine learning, or no, it's just a kind of let it go? What is the meaning of the framework in AI? What is the framework of our AI?
Yes, Ghaith, thank you for your question. I would like to start with a brief introduction by saying, first of all, why do we need normally explainable AI, and why there is this connection between natural explanations and artificial explanations. If we think about human beings during their evolution, there was a moment in time, a particular moment, when mankind had a sort of revolution, one of the first important revolutions, and it was the invention of language. Language allowed to create abstractions of the reality and to think about the reality and to define the reality in a context which was not necessarily on the same level of the experience. So, for example, if a man met a beast in the jungle and the beast did nothing, he could ask himself later, why did this happen? Why? Or what if, for example, I didn't have a torch in my hand? This was the beginning of a process of creating abstractions that allowed reasoning. This kind of reasoning became more and more precise thanks to logic. Logic forced the reasoning not to be too fantastic, let's say. So there were rules, and these rules allowed to explain whatever we wanted to explain according to specific criteria without contradictions, for example. And now if we jump, we have really to make a big jump, and we move to the field of machine learning. We started, when machine learning or statistical learning started, there were models which were intrinsically very simple, and they were basically explainable. When I say explainable, I mean that it was very easy to understand why a cause could be connected to an effect, or how an effect could determine the cause. Think about a simple linear regression. The coefficients of a linear regression, if the values are normalized, of course, are of the same scale, are enough to understand immediately the contribution of each single variable. This is an approach which is absolutely necessary for human beings. First of all, because human beings want to know why. And black boxes are generally problematic because there is always the moment when you start asking why something is happening. But also another very important element are counterfactuals. So in some cases, and this is probably our case, it's necessary to answer questions like, what happens if I do something different? Imagine the situation where you cannot immediately analyze the reality. So this kind of reasoning that was developed by human beings allowed them to simulate in their mind these processes and to arrive to a conclusion which was impossible otherwise. Now, returning to the word of black boxes. There was a moment in time when deep neural networks, or neural networks with more layers that became more and more over time, started becoming easier to build and to train. And they showed a very high accuracy. So they created a new revolution, the revolution of AI and the revolution of deep learning. But on the other side, they also created a larger gap between the so-called ground truth and, on the other side, the explanations. The ground truth is what we use to train a network. So imagine that you have a training set and you have created the training set in the best possible way. So you have sampled from an actual process which contains all information that you need for your system to work. So when you train your system, you are sure that you are covering all the cases. And you arrive to a certain result. So you observe that after training your model has a very good accuracy. Of course, I'm talking about validation, so accuracy on never seen samples. There is a problem. There are many problems, not only one. The first one is that normally, imagine that you have a classifier with, let's start with simply 2 classes. There should be always another class. In every problem of classification with n classes, there should be n+1 classes, because there should be a class including whatever is not included in the other n classes. Imagine that you want to distinguish between horses and dogs. If I show the picture of a cat, the model should say this is not, it's not either a dog or a cat, or a horse, sorry. So in this case, it's necessary to have this class. Unfortunately, this class is much larger than all the other ones. So when you train a model using this approach, you have a problem because the model is much bigger, and the amount of data that you have to allocate in this other class is much larger than the amount of data that you can use. So for the real classes. So you have to find a compromise. In general, what you do is to say, okay, we'll limit the application of our models to specific classes, and we guarantee that the images, for example, if we talk about images, belong always to specific classes. But also in these cases, we have another problem. And the other problem is that it's easy to prove that if you take an image, let's suppose that is an image of a cat, and you just add some noise, the image is almost identical. And it's possible to trick a classifier and force the classifier to output a complete different result. Again, the problem is that these classifiers, when they are robust versus something, they can become very weak versus other problems. So now I don't want to take too much time, but let's jump on healthcare, which is our main topic. In healthcare, in this case, for example, we have images. We have a lot of images. Images are now extremely important in many diagnostics and prognostics processes. But the question is, when you have an image and you are a physician, is first of all, can I trust the model? Is the model producing the actual output because what the model has detected is really the cause of what the model is predicting? And even if this can be considered true, in many cases, it's not. There are some models which can be extremely accurate, but when you analyze the reason why they are arriving to a certain classification, you discover that they are using some features which were not immediately considered important. But the model identified those features in some images and considered those features as peculiar. That's why some physicians started saying, I cannot use these models blindly. I want to have explanations. And I want to have two kinds of explanations. The first one should be an instance-based explanation, a local explanation. So given an image, I want to know why the model is outputting a result. And for images, for example, I talk about images because they are the most common. But of course, they want to see, for example, the areas of images which are really triggering the output. If this that doesn't correspond to their experience, at that point the physician can intervene and can, for example, interact with data scientists to understand why the model is working not properly and helping the data scientists in refining the models. Another reason, which is also extremely important, is about counterfactuals. And again, counterfactuals in healthcare are extremely important. We are in situations when sometimes, for example, a physician wants to know what's the difference between two therapeutical approaches. And given a model that is trained correctly, the question, what happens if I change something? Of course, I cannot test this on the patient. I want to use the model that has enough experience to explain me what can happen. Clearly, in terms of probabilities, we are not talking about precise answers. And that's why explainable AI became more and more important. And nowadays, almost any medical system has to cope with explainable AI. Otherwise, there are risks in so many cases to find reluctances and resistances. But we have time to discuss about details later. So I leave to Tom for the next question.
Yes, Tom, right now I think you are okay. You are able to hear us, correct? Okay. So Tom, I'm here according to what Giuseppe explained to us. Thank you, Giuseppe, for this. You give us better landing for the subject. I have two comments about this. The first one, and I want Tom to help me with that. The first one, when we are talking, yes, the physicians or the healthcare service providers, they need to understand why. But when we go to the ground truth from their side, most of the time we are unable to understand why they make this decision, for example. They have their own studies. So this is not
Faith, I
reflecting
apologize.
from
I
their.
have lost audio again for some reason. I can't. I think I know what you're asking, but I don't think it's anyone's fault. I think the system doesn't like me this morning. I will try some other things real quick. So sorry to everyone.
Okay. If you are able to
It's
hear me
interesting. At
now.
the beginning, it went away and then it just came back inexplicably. The sad reality, it's a good illustration of what we're talking about. I cannot always understand how Zoom works and doesn't work. Can you guys hear me?
Yes.
Okay, I just cannot hear you. Maybe we can resort to sign language. I can go to another system too. Let me try that. It'll give me mouse ears, but at least maybe I can hear you guys. I just don't even know what to try right now.
Okay, I'm
1 minute
gentlemen.
to switch.
Everybody is
What a horrible
joining.
thing to
Yes,
happen in the middle of this.
I will wait for Tom. Just 5 minutes until maybe he is able to back to us. If not, I will go with the question that right now it's asked to Giuseppe. So
I'm not reading all the questions because
no, I will forward it to you. Don't worry.
I'm leaving this to you.
Okay, Tom. Okay. So Tom, again, we lose your. He is unable to hear us.
Okay, now I'm trying to get Zoom to accept this new device.
Tom, forgive me, I will mute you now, and I will back to Giuseppe until you back again to us. So Giuseppe, I'm just going to just ask about what we mentioned right now. You told us when we are talking about healthcare or about physicians, sure, they are dealing with very critical sector physicians and they need clear explanations. But is the statistical evaluation of the
Maybe I
model
try to disconnect and reconnect while you and Giuseppe continue.
Okay. Okay. So I will continue right now. Is it enough, the evaluation method that we have when we are going to tell that this is the statistical evaluation method is enough for the physician, or no, we really need, in fact, the physicians themselves, they are not giving us that level of explanation. So why we have to do that from our side? And also, if this will delay our processes, how much we should wait until, for example, Eric Topol yesterday or day before yesterday was talking about there is some models is performing better than physicians because we are trusting mathematics. So why we have to wait, and what is the, let's say, the business value of explainable AI for the physicians?
Absolutely, it's true that some models will perform better, has been proven, and I'm sure that in the future, all the models will perform in general better than physicians, simply because not because they are better than physicians, but because the resources are completely different, and we can use more and more powerful resources. So this is absolutely true beyond any doubt. The problem is another. The problem is that we, first of all, we cannot remove the physician from this process. We are not thinking about replacing physicians with machines. And the physician represents the fulcrum of the whole process. So the explanations are not necessarily in every case. We need to be clear also about this. There are many processes during imaging a diagnosis. A diagnosis is made up of many steps. If you take, for example, a blood sample, the physician doesn't want an explanation. He trusts completely the results. Of course, if the value doesn't make any sense, it's out of the boundaries, can ask for further tests, but in general, in some cases, we don't need any explanations. Here, we are talking about particular applications where the problem that we are facing is very close to what was considered the domain of the intelligence of human beings. So in those kinds of problems, the explanation can become helpful for, first of all, to help the physician understand. But also when the physician understands, the physician in some cases can also be helped in learning how the system has arrived to a certain conclusion. So it's, I always use the term companion, because in this case, it's like when you are a physician and you have in front of you an image, you have an idea, and you also have a certain likelihood. I mean, you think that probably everything is as you have imagined, but you ask for another opinion. Why you do this? You do this because it's normal that in some cases, some uncertainty cannot easily be removed. And the only way is to have the explanations of other people. You normally don't like a yes or no, but you like, for example, an explanation saying, yes, it's this because as you see, this area has this particular aspect. I'm just talking in a very generic way. I'm not talking like a physician. I'm not a physician. So forgive me if my language is very inappropriate. But in general, you want to have a confirmation that is supported by evidence. And this is the reason why we look for explainable AI. So of course, we need to start with a good system and very accurate systems. I absolutely agree that this is the first step. But it's also helpful in many cases, in particular, when you see some resistances from physicians to adopt the systems, is helpful to invest some time. Returning to the beginning of your question, we need to say one thing. Nowadays, there are no silver bullets for explainable AI. There are no methods which are perfect, because the problem is extremely complex. We have a very, very, very complex function, and we want to understand just like it was a simple linear regression. This is clearly impossible. So there are generally assumptions and approximations. These assumptions can be valid in some cases and can be completely wrong in other cases. In my teams, we have compared different methods together with physicians, and we have seen that some methods will output something reasonable, while other methods will completely make mistakes. So it's necessary to invest some time in comparing the results and always having somebody with experience that can confirm that what you're doing has a meaning from a medical viewpoint, not from a statistical viewpoint, data science viewpoint, because otherwise you can never improve your models. So I think.
No, thank you for your answer. Right now, just to have it more clear, what is explainable AI, and especially in healthcare? Are we talking about techniques or just explaining the outputs, make it more clear for the doctors? Or what is exactly the explainable AI? Are we going to change the framework that we use to work on it, or it's something else?
Explainable AI is a very generic term. It simply means that when you have a black box, so whenever you have a model that you cannot analyze internally so that you don't know the dynamics, you can find some ways, or clearly some ways which are not natural. Just to make an example, I always invite the people in this case to think about a linear regression on one side. That is the simplest model where everything is explainable. You have y equal a times x plus b times z. A and b are enough to explain the model. When you have a neural network, a deep model, you have a bunch of parameters. The number can be really, now with GP3, I was reading, we are talking about trillions. So we are talking about numbers which are beyond any possibility of understanding. And if we think about the complexity of the functions, so we put together all these functions and we combine them, the result is absolutely beyond any possibility of comprehension. So explainable AI is a way to solve some problems. And the first problem is understanding the connection between output and input in a global way. So this is the first idea that came into the mind of the researchers. So it's I have a system, I want to understand, imagine like a set of rules, for example. This is clearly the easiest way to explain, but in general is impossible. But I try to find out some sort of a sequence of if-then, and this is the global explanation. This was originally the way, for example, some systems worked, some very old system worked. And it was very helpful because using this approach, it's very easy to understand the logical process that starts from a piece of information and arrives to a result. But unfortunately, again, this is not feasible in general for very complex systems. So we need to look to local explanations. A local or instance explanation is based on a specific input. So at that point, we have the input, and what we do is not modifying the system, but it's applying some, let's say, filters, let's call it this way, that takes the input, and then they use the structure of the network, the gradients, for example, of the network, to understand how the activation functions are moving throughout the network to arrive to the output. At that point, it's possible to understand that there are systems which are easier. For example, there is a system called LIME, like L-I-M-E, which is a linearization, tries to linearize around a specific point. And this is a very simple solution that was adopted many years ago in many problems where the functions were nonlinear and it was very difficult to treat them by hand without a computer. So by performing this local linearization, it's possible to have an idea of the behavior. In other cases, it's necessary to have like SHAP, for example, or DeepLift, other methods. They are based on stronger assumptions. And in that case, they try to explain in a more robust way. When I say more robust, means in a way with less assumptions, so they are more flexible, and they try to explain, to associate the amount of output with the amount of input, and try to find a correlation. So they try to answer the question why. The question why is exactly the main question for explainable AI. But it's also possible to try to find a global explanations using, for example, with SHAP, it's possible to try to find global explanations using trees. And this is very common. Decision trees have already a sort of explainable framework inside them. But for example, when you start using XGBoost, for example, or boosted trees, so systems which are a little bit more complex, this explainability becomes more difficult. And using also SHAP, for example, it's possible to have a global explanation of the importance of the features, which is not meant only as the importance like in the classical decision trees, but in general, we try to understand how a feature is contributing to the output, how a feature is contributing in terms of positive or negative effect, and how a feature is affecting the population. So how a feature is concentrated, so is a feature which is very specific, or is a feature spread to a large number of people, and the variance of the feature. So these diagrams are very complex in general to explain because they have a lot of information inside. But we try to say, for example, this feature is very important to explain the output, but the variance of the feature is very limited. So the majority of people, I just make you an example to be clear. For example, for COVID, the mortality for COVID is strongly influenced by age. So clearly, when you look at that value, you see that that feature in general has a very short, a small variance around an age which is higher than, I don't know, 75 more. Clearly, you don't see a very high variance. But the goal in that case is understanding how the feature is influencing the output. This is very helpful in prognostics. And this is quite different than the approach we discussed before for images, but it's very helpful in prognostics because it helps the physician to understand the factors that can influence the risk associated to specific diseases. And the fact sometimes they discover that some factors which were not immediately considered very important when analyzed together in a bigger picture, they can become extremely important. And they can adapt their therapeutic approaches.
Tom, just as a comment again on Giuseppe, I hope right now everything is okay.
Yeah, I can.
There is two things. First, we are looking always for the answer of the question why, and because maybe it's the most asked question. But is the intelligence is to know why or what, to answer why or to answer what. This is the first idea that that mean if we understand why, what we are going to do, when artificial intelligence is going to help us, not to only discover some features or make some understand what's the factors that affecting the prognostic decision or prognostic probabilities, but what we are going to do. Artificial intelligence in healthcare, is it maybe not in healthcare, but in healthcare in specific? Is it able to tell us what we have to do? For example, instead of this lockdown that happened in the world, do we have another solution? And if we find another solution, do we have to answer why we have them to make this solution? Even in our life, I'm just going to make this example. In our life, sometimes we make decisions and we don't know why. We are not waiting by instinct. We are doing this because we have to be safe. We have to be survivors. So why is very important, and which is more important, why or what, especially in healthcare?
Yeah, this question about having to completely explain something to make a decision, hardly any of us do that each day with even big life decisions. There are tools that can help us to make better decisions, but in the end, and I hope this is getting to your question, I think it's best to approach this whole explainable AI thing with great caution. And I wish we could have more discussions on this with those that insist on explainable AI. Here's what I mean. There's so many things in the sciences and even in our daily lives that we use and accept without even being able to explain why. In fact, I would politely contend worldwide that we do not understand hardly any whys. If you look at gravity, we don't know why gravity does what it does. We just know to very accurate detail what it does. We could go on, electricity, etc. Giuseppe gave the perfect example. If we look at linear regression versus a deep neural network, well, the explainability between those two is the ends of the spectrum. One almost completely unexplainable as it gets very large. Convolutional front layers help us a little bit, but I think the important point is just like when we're going at a problem, I think Giuseppe and I would agree that I just love to start with tons of visualization and consider what features I can drop out, what feature engineering I might need to do. And someone out there that loves deep learning may be saying, well, Tom, just let the neural network do that for you. No, it's still important to see, let's do some front end work. Let's see what we could get from a simpler explainable model. Let's do some feature engineering. Because as we all know in the end, the classic question that's really not a good question is, what's your favorite algorithm? You know, it's the one that does the best job. Since you have to go through the process of analyzing different types of modeling anyway, I love to start with linear regression and feature engineering and PCA because it helps me to understand the problem. And so for me, that's the explainable part. But if at the end of the day, for the current data set, the current round of evaluations, the deep neural network does the better job, and I have enough data to train one in the first place, well, okay, you can't explain its results, but by having all that other modeling, those ones that are a little more explainable, you can help to give intuition to the unexplainable models. And I think by presenting it as a suite of work, instead of just this, here's my solution, it helps everyone. For example, if one of you were taking a university level class from me and I handed out the exam and you handed back just the answers, you're going to get an F, right? Because the real art of being a good technical person is to show your work. And I think for those that are struggling with unexplainable AI, we need to present the body of our work to say, we tried these models, and if you look at just linear regression, which we don't advise you using in this case, we can see these factors are important. We could have dropped these factors out, et cetera, et cetera. That can even help you with the front end work to a deep learning network and possibly simplify it. But I think the way to bridge the gap for those that are insisting on explainable AI is to just show them the body of our work more. It means longer presentations, justifications, but at the end of the day, I think we're going to really hold our arts back in data science, machine learning, AI. It's all muddled terminology at times, but we're really going to hold the advancement of our arts back if we don't help people that insist on explainable AI get over the hump. It's just going to potentially hold us back.
Okay, I will create one scenario, one bad scenario maybe, just to I need your comment, both of you, on it. For example, if we have right now another way, not the PCR, just to detect COVID, for example, right now in this day, which is faster, for example, and cheaper. And we tested over a huge data set from different resources, and we found that it's working well. But the radiologist or the authority, whatever, they refuse to use it because they are unable to understand why. Should we accept this? Here is my question. Since Giuseppe, you tell us there is no silver bullet for explainable AI. Okay, I understand it. But should we accept this delay? How much we have to wait, for example? Yesterday, Bill Gates was tweeting that we have to let the innovation to lead the world, because he was talking about what's after COVID and what will happen. So how to do that if we are unable to? I think Thomas Alva Edison, if somebody asked him why this lamp is lightning, there's no electricity right now. So maybe I'm aggressive against explainable AI, but it's not about this. My point is, when we are going to run away or move from the researchers or a lot of researchers and a lot of work on this to the real solving real problem. I need your comments on this question, just this scenario, because right now we are still, some countries, they are out of COVID, some countries still suffering from COVID. So just this scenario, in your opinion, what we have to do?
Should I go first or Giuseppe?
First, go on, please.
Well, this is complicated. It's got many factors, many features to this modeling problem. And so, for example, in a situation like with COVID, and someone feels that they're really at risk, they've contracted COVID and their conditions are not good, I think it should be left to the individual. Do you want to take the risk of trying this thing the authorities haven't approved yet, but it has a lot of good evidence for success? We leave the decision up to you. And I think we need to respect the individual in that case. There's even a case like this in our country where some doctors feel like they have an outstanding treatment for COVID, but because it's not been approved by certain authorities yet, they get in trouble for speaking out about it. I think it's really left at a conscience level, in my opinion. But when you take it out of the realms of COVID and take the more abstracted question of do we accept things that aren't super well understood or proven and start using them, again, I think the urgency of the situation warrants allowing the individuals involved to make the best decision they can. We can make seemingly very well informed decisions with seemingly very explainable features and still be wrong. At a certain point, we have to move forward.
So,
yeah, I try to answer from a different viewpoint. Yeah, I agree with Tom, but on the other side, I think that in this particular situation, it's very difficult that we don't understand completely. Normally, when you start, when for example a new drug is developed, some processes can be partially not fully completed. I mean, you can have a global understanding of the process, but you cannot know everything, and that's why we continue experimentation. But it's very difficult that you have a solution that works, but you have no idea about how it works. And this is very dangerous, in my opinion. So I would say that it's not a problem of explanation, because we already, in some cases, have an idea. For example, the drugs that have been tested for COVID had a relationship with COVID or viruses in general, let's say similar viruses. Clearly, someone decided that was a good idea to drink the sanitizer, because in that way it could sanitize internally, and they sanitized completely, and they sanitized in the graveyard. Unfortunately, yeah, this is exactly the same situation. I mean, we have to understand that it's very difficult that we make decisions when we are completely unaware of them. So we normally have an idea. We sometimes don't have a full picture. We don't understand completely some mechanisms, but we have enough evidence, for example, And the evidence shows that the process has a relationship. I make another example. The brain is a sort of black box in some way. There are some processes which are almost unknown, but there is a lot of evidence that some neurotransmitters have a particular influence, for example, on the mood. This is based on evidence. This is not just based on something that is just observed. It has been experimented, it has been analyzed under different conditions, in different scenarios, under different situations. So there is there are enough elements to say we have an understanding that this element has a very strong responsibility. Maybe we cannot fully understand why, but we know that this element has a very strong responsibility. So to answer your questions very straightly, no, absolutely no. If a solution, if there is a solution that doesn't work, or sorry, if a solution that works, but we have no idea how it works, well, we should think about how it works, because maybe it works because it's just destroying everything. It happened in the past. Some solutions were considered working, but they worked because they made more damage than helping. So in general now, for example, for the vaccine is the same. The vaccine must be accelerated, but there are some phases that must be undertaken, and they are absolutely mandatory, because even if we have made a lot of vaccines, the next one can have some side effects that could be lethal in some cases, and we cannot take this risk. So we must rush, absolutely, but at the same time, we must take the necessary time to find something that can save lives and not create other problems.
Just in follow-up, I agree. I think it's always great to seek more understanding. But just because we don't understand something and yet we can see by evidence that it works doesn't mean we should avoid using it. In fact, by starting to use it, we might have a better chance of explaining it better. But again, there's always tools to help us understand the overall situation better, even if it's not the tool we employed to get the job done.
Okay, thank you. I think I have better understanding right now about what we have to do. I have three sentence or statements. I need your comment also on it. First, just if you agree or not and why. We are passionate about AI because it helps to perform tasks faster. Or it's new electricity. It gives us new possibilities, something that we don't have in the past. Is it only about the time and the cost, or no, we are able to create something totally new from what we have on our history?
I go on. Just like electricity, this is an Andrew's sentence. AI as a double role is a new electricity because it allows to automate some processes, to speed up some processes, to improve some processes. But also on the other side, electricity allowed to create completely brand new things that were not even imagined before. The word that was disclosed when electricity and all the related fields were studied deeply and experimented opened completely a new era. The era starting from Edison, Westinghouse, Tesla to our current days is completely different than the period before. So I think that AI has a similar role because AI can help speeding up in, for example, in drug discovering. This is a very topic related to healthcare in drug discovery, drug efficiency. AI is extremely important, can speed up search problems that were normally sometimes long years. They required decades or years. And it's possible to speed up them. A new antibiotic, I read an article a few, I think, weeks ago, was discovered in 47 days. This is something extraordinary. Some drugs have been discovered after 10 years. That's the difference. But on the other side, we can find out things, solutions, ideas, applications, which were completely science fiction in 20 years ago, or even probably even less. So yeah, I completely agree. I think it's even more from some viewpoint, because electricity, I want to say electricity has some limitations. AI is like a new word that can expand and can become even bigger. It depends on us. Tom, to you, sorry.
Yeah, no, that's great. I was enjoying listening. My answers maybe disappointingly pragmatic and lacking philosophy. I'm a guy. I like to build things and I like to have a lot of tools at hand. I just see it as a new tool set. I feel lucky to be alive in this age. I look back, I see the advancements, I see the shoulders of the smart people we stand on. And I just look at all this and think, hey, thanks for the new tools. I've got them in my shop now, and this shop. And like I said, we've got more tools now. We've got more methods to try. I'm going to try them all for this particular situation and see what works the best. When I can't understand it as well, I will try to understand it better as I move forward. But I'm inclined to just use the best solution at the time that the evidence supports, with plenty of testing.
Okay, another question I want to ask, or another statement, let's say. It's about the future, just from your point of view. Let's say your comment, it will be for our history. We will check it later, maybe after 10 years or 20 years. That means here it's clearly that each finding, it will push the humanity. This is my opinion, in fact. So this is my opinion. So always the human, it will be faster than machine. There is no need to be afraid about the intelligence when we, let's say, when we have intelligent machines, because humanity, it will be faster always. Just like what Garry Kasparov said previously in TED session, that don't avoid the technology. Don't be afraid about the technology or the new findings or the new techniques. Just work with it, and you as a human will be better. So this is, in fact, I'm totally convinced with that. Or should we be afraid about some kind? And I think, Tom, previously you shared some videos with me that you make me afraid. Exactly.
Yeah.
So, Tom, would you start with this?
So question is,
our future as a human, is it one day we will find that we have a clear, let's say, battle between machines, intelligent machines, and the humans, or no? This will never happen. Some kind. This is the question.
Forgive me, Ghaith. Basically, do we need to fear the future of where machine learning and AI are going? Is that the question?
Exactly.
Oh, good. I did understand. So this may be naive of me, but I don't completely appreciate it at the fear of the future of AI. I love to listen to Elon Musk because I like to see the barriers he's breaking. I used to think when I was a young man, why can't one of the technical guys be the business leader? And well, I am. And But when I look at the future for AI, I look at these deep questions we're considering, that can machines learn to think? Can they learn to feel? Um, I think they will become powerful, yes. But we have to remember, we're the ones creating them. We're the ones designing them. We're the ones programming them. So if they get to these higher level functions that approach being sentient beings, and they end up doing harm to humanity, that was our fault. You could say the same thing about guns. I mean, I don't want to get into an argument on gun control. I just want to say the problem's not the gun, it's the person holding it. So really the thing we need to fear with AI is it will become powerful. The bigger question is, will humans use it in a way to help each other or potentially harm each other? I hope it's not to harm each other.
In fact, I have a comment here, but I would like to hear from Giuseppe first.
Yeah, Ghaith, more or less, I think it's almost the same thing. I mean, the problem here is not about AI. The problem is about the application. AI is a technology. AI can be used to save a life, or drive a missile, or to kill people, to do everything good and bad. Being afraid of AI and the development of AI, in my opinion, and even if, I mean, I know people like Elon Musk said this, and I respect Elon Musk because I consider him a genius. But on the other side, I would ask him, do you know how many atom bombs are available in this moment on the planet? Do you know if somebody gets crazy, can start a third world war? And why do I have to be afraid about AI when we know that we have a lot of other problems, a lot of other dangers, and we are not doing anything to prevent those dangers? So yes, AI is powerful, just like a knife was powerful, but a knife was the first instrument used by surgeons to save lives, became scalpel, and the scalpel is needed if you need a transplant. So yeah, I agree, it's powerful, but I'm not scared about AI. I'm scared by human beings. That's quite different.
And here's my comment: is what happened during COVID is enough to return us, all of us, as a human and as experts, to be more human? Is what happened in COVID when 3 billion or 4 billion person stuck at home. And for sure, there is a lot of mortalities and there is a lot of still people, they are still have this infection. It was enough to tell us that we are human and we have to forward our efforts as even as AI expert to the healthcare and education more than military or armies or, let's say, marketing. This is, in fact, this is the real question behind the whole session for me, especially after what's happened in Lebanon yesterday or day before yesterday, which is by mistake. There is no war there. But in fact, this kind of mistakes, and when you see that this is only for my Lebanese friends, please check about your political people. They are trying to find fight while the one of the best and more beautiful cities in the world, it's destroyed. So is what happened in COVID is enough for us to become human again? I will close with this question and then I will be open for everybody to ask.
If you want, I can continue. In this case, I'm sorry to be pessimistic, but human beings have this nature, and it's not the first time. COVID was not the first problem. Plague appeared many centuries ago, and wars were repeated so many times. The Spanish flu was about 100 years ago. So I think that human beings have a double nature. One nature is to help each other. In some moments, we are ready to help. I read this morning that all the countries are many countries are sending help in Lebanon, and they want to help the people. Of course, we want to do everything. But on the other side, we want to be powerful. We want to be respected. We want to have boundaries. We want to build new boundaries. And this is a double nature. So I think that COVID just showed how humanity is fragile with respect, as Bill Gates said. Bill Gates was one of the, it was like a prophet, because humanity is so fragile that even as a virus that is exactly the same virus of a normal cold, a modification of a virus, which is very simple, nothing particular, can create a mess like it happened. So I don't think it will change a lot. I think that for sure there will be more and more people involved in initiatives, and these people can make changes. And we have to rely on the work of these people, of the people that are now working in Beirut. They are digging. These people are, or the people that helped with COVID, staying 24 hours a day in the hospital. There were people I knew personally that stayed 24 hours continuously. So those people show humanity. But on the other side, we know that there are people who are thinking about themselves to be more powerful, to have more money, to have more power.
Tom?
I was taught when I was a young man, there's basically three aspects to human beings. There's their body, their physical appearance, their physical abilities. There's their soul, which we typically think of as their personality, and then there's their spirit. And by the way, Giuseppe, great answers. I agreed with you. I'm really just tagging along on what the good stuff he said. But it dawned on me as I got older, I kept testing this, and I started thinking, how do I see the spirit of another person? And then it occurred to me, oh, when they're under stress. Right now, humanity, because of COVID, is under stress. And we get to see the best and the worst because of it. And to those that are showing the best human spirit, thank you. You inspire us. To those that aren't, we're praying for you. And that's the real answer to this AI thing. It will be powerful, but I think if we use it to influence the spirit of humanity, look at the good we can do, and that becomes more popular, great. But again, it's fragile. Those that are injured act out in bad ways. They're injured in their souls, spirits, and hopefully we can control those that would use AI in ways that are not helpful to humanity. We can protect ourselves from those types of people, but we can also influence them to turn those talents to good, to serve their fellow man.
In fact, what I'm thinking about this, it's a human person, or what makes the human or the man is a human. It's the ability to be, let's say, his instinct, his compassion, his maybe the conflict, that what moves us. It's not about the ability to learn or the, let's say, the intelligent, how much he is intelligent. In fact, there is some monkeys, they are able to make some task faster than a man, but they are not a human. So, and here is the great thing, we are human at the end. Everybody, when you look at us, all of us, we have this head, hands and legs, but at the end, what makes us really human, how to activate our, let's say, untouchable senses that we have, just like how you are able to help, why you want to help, how much you are compassion, how much passion you have in your field. This is what makes us a human. This is my opinion on this. Thank you for this. I think from technical and from spiritual side, it was very nice speak to you unless the technical, let's say, difficulties that you find, Tom. Sorry for that. I hope this is
no one's fault. It's the Zoom world we live in.
Now I think we have to go to the question from the people. There is a lot of question is appearing to me. I will prefer just to let the people ask it immediately. So let's say start with Thomas. Thomas, if you are able to unmute yourself and ask your question, please.
Sure, thank you. My question to you is whether explainable AI in any circumstance will reduce accuracy of an AI or machine learning model.
I think it just depends on the specific case. Like it's almost become an ubiquitous explanation. There's no free lunch. And each new problem, actually each new data set, you really need to test a host of models to see which one's going to do the best job at the time. I'm a big fan of automating model selection, automating the data flow, automating the data cleaning. You know, I think when linear regression can do a great job, especially with some heavy duty feature engineering and feature reduction, use it if it's adequate accuracy. But yeah, many times if you have enough data, deep learning, if it's being accurate, use it. But keep testing. The idea that you stop at this model and you never switch to using a different model for that flow of data over time, that's not a good practice either, in my opinion. You need to constantly, this is an ongoing process of seeing, okay, 3 months later, what model might generalize better and serve our needs better? Oh, it changed. Well, let's use that.
Giuseppe.
Thank you.
Okay.
Please.
Okay.
About
yes.
the question.
Yeah. Well, my very quick answer is that in general, explainable AI is like sort of plug-in. So you train your model is has a certain accuracy. Explainable AI has nothing to do with the dynamics of the model itself. So I would separate completely the accuracy of the model from the explainability. There are two different things. So there's no impact, in my opinion.
Also, another comment from my side. Yes, I think sometimes we don't have to take care about the accuracy if we have a clear explanation. So the explainability, sometimes it's more important, sometimes it's not. So for example, if we are looking for the accuracy for just to mention achievement or for research accuracy, it will be okay. But one of the most popular problem that we have, that you have a huge accuracy on one data set, but when you are going to test the same model on another data set, this accuracy, it will not reflect. So explainability, in fact, maybe it will be more important sometimes than accuracy. And I agree with Giuseppe that it's something different, something not related to it. So I hope this has answered you. Ronak Jain, also, please, if you are able to unmute yourself and ask your question.
Hello. So we were talking about the dangers of AI. So can we create an AI to detect the dangers of AI and we can get rid of it?
Yeah.
Who would like to start? I will keep this because I want to start.
I lost the last part. Can you?
It
would be like AI detecting AI.
Can an AI detect a wrong AI?
Okay. Cool.
Please go, G.
Yeah, Jay. Okay, Giuseppe. Start with that.
Well, in this case, as always, we should start, first of all, defining what wrong means from an AI viewpoint. So an AI that can detect an error on another AI is very simple if it's just a problem of a metric. The problem is that an AI just like human beings, when works with internal representations, will create some sort of world where there is no true or wrong. The true or wrong depends on what we want to consider true or wrong. So the question itself is very interesting, but it's necessary to be very precise in understanding. Okay, well, it clarified deepfakes. Deepfakes is not wrong. Deepfakes is, it's not a wrong AI. An AI can probably compare the original with the deepfake and can find the differences if they are shown, if there is some differences. But indeed, a deepfake has nothing fake, because when you see a picture and when you are not able to understand if it's true or fake, imagine like the reproduction of a painting, for example, not necessarily a deep fake. How can you pretend that an AI is able to show that this is false? There should be elements. So the problem is when we think about a wrong, something, when an AI is trying to cheat another AI, this is like a sort of Turing problem inside the Turing problem. Well, this is something very, very complex to discuss, but this is probably something that requires still more time to arrive to this point, because it requires the will to create something to trick. But right now, everything is true. There are no wrongs. The wrong is only what we define as wrong. I don't know if it's clear, my answer, but...
For me, it's clear. And in fact, I found it very nice. Tom, I think he has something to add.
Oh, the question is very interesting. And I think first AIs need to get to a point where we think that they are able to begin to deal with ethical questions. But let's say that there was an AI that could deal with ethics. I would then postulate, yeah, but what set of ethics? Worldviews very strongly affect what people think is right and wrong. And the reason we have arguments among ourselves in humanity is because our worldviews differ and our moral sets don't completely overlap. That's where the tensions arise. I almost wanted to use a joke to illustrate what I'm trying to get at. There were three guys arguing over the greatest technological innovations of the last 200 years. And one said the internal combustion engine, and they all thought, yeah, that's pretty good. But no, I think it's the microchip. And yeah, it's pretty good. And they looked at the third guy. What do you think? It was the thermos. I can't believe y'all didn't say that. Well, why do you say that? That's so simple. Well, think about it. It keeps the hot hot. It keeps the cold cold. But how does it know the difference? Ta-da. The point being,
this is in fact a very deep joke. Okay.
But the point being, if we apply it to this question that Ronak has posed, okay, AIs are able to deal with ethical questions now, but which worldview are they using? You know, how do we know we would just start arguing with AI then based on our own worldview that we're currently convinced about?
Okay, I think there is no other question right now. It's the time for you. First, thank you. Thanks for everybody who's participating, asking, just attending. Thanks for everybody who's just watched us on YouTube. And thank you, Giuseppe and Tom, for your joining today. I enjoy this. I hope everybody is enjoying this. I will keep the final word for you if you have anything to add. We start with Tom.
Oh, I love these sessions. The only disappointment is we're not hearing the thoughts of everyone out there. It's a little humbling to be listened to so much, and I'm sure there's a lot of great minds that could add a lot of additional points. There's always so many great things to discuss, so little time.
Yeah, yeah, absolutely. I was thinking the same. It would be fantastic to have these sessions like every day, you know, when you stay in front of a chimney and you discuss, because there are so many questions which are extremely long. They can trigger long discussions. And unfortunately, it's impossible to answer them in a short time. Also because it's necessary to think. I mean, probably if I think tonight, I say, oh, I could have said this during, because it's normal. It's an ongoing process. So I'm very happy, yeah, to be here. I thank you, all the participants, all the people, and of course, you, Ghaith and Tom, for the event. And I hope that everything was clear. And I'm looking forward for.
Yes, I'm looking forward to mention this right now because Ronak, the same one who asked us, he mentioned that I enjoy and it was really interesting, need more sessions. So I will tell everybody about our project to have this session as monthly session each Saturday, each second Saturday of each month. We already discussed about this, Giuseppe and Tom. So, but it will be shorter. So I announced it for everybody here and then on LinkedIn, and during that, I hope it will be helpful for everybody.
But next time we do it 3 a.m. for Tom.
Yeah, sure.
No, this was fine. In fact, it's kind of a bonus. Oh, I get to go back to sleep after this.
Okay, we will try to find better time for sure. I think after 7 hours from now, it should be suitable for you, and I think it's suitable for us, me and you, Giuseppe. So
well, just so you know, this time works good for me because my family's not running around behind me, so it works great. Very quiet here.
Yeah. So I have to move the camera so you can see my family, what they are doing right now.
That'd be great.
Thank you, everybody. Thank you.